Hi, this is Wendy Lightheart, and let's look at how to multiply and divide rational expressions. First, we'll look at multiplying rational expressions. If a over b and c over d are rational expressions where both the denominators are not equal to 0, then when we multiply them together, we end up with the new rational expression a times c over b times d. So in other words, we multiply the numerators together to get the numerator of our answer, and we multiply the denominators together to get the denominator of our answer. However, we usually want to simplify first by canceling any common factors before we perform the multiplication, very similar to when you multiply fractions. So here are the steps for multiplying rational expressions. The first thing you want to do is to factor all of the polynomials in the numerator and denominator completely. Then you will cancel factors that are common in both the top and the bottom. After you've canceled all the common factors, then you want to multiply the remaining factors in the numerators to get the numerator of your answer, and then multiply the remaining factors in the denominators to get the denominator of your answer. So let's look at an example. Here we want to multiply these two rational expressions. So remember that the very first thing you want to do is to factor everything completely, because we want to be able to cancel any common factors, and the only way to do that is to factor everything so that you can see the factors that are common. So if you look at the numerator of our first rational expression, and you want to factor that, the first thing you should be thinking is, does it have a common factor? And the answer is yes. We have a common factor of 10 that we can factor out. So when we factor out that 10, the remaining factor will be x minus 7. Now let's look at the denominator of that first rational expression. Once again, the first thing we check for is the greatest common factor, and there is a common factor of 2, so we'll factor that out, which will leave us a factor of x plus 4. Now those two are factored completely, so now we'll move on to the numerator of the second rational expression. Notice that there is no greatest common factor in that expression. However, notice that it's a difference of 2 perfect squares, so we can factor that as x plus 4 times x minus 4. Then the denominator of that rational expression, we look for a greatest common factor first, and there is a common factor of 3, so we will factor that out, and we'll be left with a factor of x minus 7. So now all of the numerators and denominators are factored completely. So now we're ready to cancel common factors. And this is really important to understand, that you have to factor everything before you can do any kind of canceling. Many students want to start canceling right off the bat, but you can only cancel common factors, therefore you have to factor everything first. So notice that we can cancel the x minus 7 factors, because there's one in the numerator and there's another one in the denominator. And then also notice that x plus 4 is also common, one in the numerator and one in the denominator. And if you look at the coefficients that were pulled out, these common factors of 10 and 2 here in the front, we could reduce that because 2 goes into 10 5 times, so we can cross those out and we'll be left with a 5 on the top. So now we've canceled all the common factors that we can cancel, and we're ready to do the actual multiplication. So remember, to do the multiplication, once you get to this point, you just multiply all the remaining factors in the numerator together. So all we have is a 5 and an x minus 4. So those two will get multiplied together on the top, and the only thing left on the bottom is a 3. Now you can leave the 5 factored out if you want, or if you want to distribute to get rid of those parentheses around the x minus 4, that's okay too. So these are both considered a correct answer in simplified form. Okay, let's look at another example. Here's one that's a bit more complicated. We've got lots of different variables and more difficult polynomials to factor. So let's take a look. So remember, the first thing we have to do is factor each numerator and denominator completely. So if we look at the first numerator, 2x squared plus 8xy, first thing you want to look for is a greatest common factor. And notice we do have a common factor of 2x. So we'll pull that 2x out and we'll be left with x plus 4y. Now if you look at the bottom, notice that the bottom is a difference of two perfect cubes. X cubed is a perfect cube, obviously, and 8 is a perfect cube, so 8y cubed is also a perfect cube. So you may have to look at the formula for factoring a difference of cubes. Basically, the first term needs an x cubed to get that first term, so x is going to be the a in that formula that you probably know or can look up. And the second term comes from cubing a 2 and a y, so 2y would be the second term. So we have x minus 2y, and then the trinomial that goes after that would be the first term squared, so x squared. And then we multiply those two together, so that x times the 2y would go second. And then take the second term of that binomial and square that, and that's what we get for the third term. Okay, so now let's look at the numerator of the second rational expression. Now this does not have any common factor to pull out. And notice that it's a trinomial who has a leading coefficient that's not 1, so you would need to use the grouping or AC method to factor that, or you could try trial and error. And when you're done with that, you should end up with the two factors of x minus 2y and 3x plus y. And that one is factored completely. So now look at the denominator of that rational expression, and we look for a greatest common factor, and there is a common factor of x. So we'll pull that out, and we'll be left with 3x plus y, which will not factor any further. So now all of the numerators and denominators are factored as far as they can be factored, and we're ready to cancel common factors. So notice that we have an x factor in common, one in the numerator and one in the denominator. We also have x minus 2y in common and 3x plus y in common. But that's all we have left. So in the numerator, if we multiply the numerators together, we'll just have a 2 and an x plus 4y factor. And we can leave those factored if we want, or we could distribute the 2. That's up to you. And then we only have one factor left in the bottom, this trinomial here. So we'll just take the parentheses off of that to simplify the denominator. And that's our answer. Okay, let's look at another one. Here we are going to multiply these two rational expressions. So the first thing to do is to factor everything. So again, if you want to pause, you can do the factoring first and then check to see if you get the same answer. That's fine. So first we'll look at the numerator of the first rational expression. Notice there is a common factor of 2 that we can pull out. So we'll factor out a 2 and we'll be left with 4y plus 1 as its remaining factor. And then the denominator underneath that, there is no greatest common factor, but it is a difference of squares. So that will factor into y plus 3 times y minus 3. And the numerator of the second rational expression doesn't necessarily factor, so we'll leave that alone. And look at the denominator of that fraction, and notice that there is a common factor of y that we can pull out, and that will leave us with 4y plus 1. So now we're ready to cancel common factors. So notice that we have a 4y plus 1 in common that we can cancel. And the 3 minus y and the y minus 3, remember those would be considered opposites of each other. They're not exactly matching. However, the signs are exactly opposite. Notice the y in the top is negative, the y in the bottom is positive, and the 3 on the top is positive, and the 3 in the y minus 3 factor on the bottom is negative. So we can cancel those out, but they don't cancel out completely. They actually leave behind a factor of negative 1. So whenever you have factors that are opposites of each other like that, they will cancel out each other and leave behind a factor of -1. And we always leave that factor of -1 in the numerator. Okay, so now we've canceled everything that we can, so we'll multiply what's left on the top. 2 times -1 would be -2, and then on the bottom we have a y plus 3 and a y. So usually we would put the monomial in the front, and you can keep it factored like that, or you can distribute the y, that's okay too. And that negative that's on the 2, remember with a fraction you can put a negative sign in the numerator, or you can pull it out front of the entire fraction. So either of those would be considered correct. Okay, let's now look at a division example. So here's the definition of dividing rational expressions. So if a over b and c over d are rational expressions where the denominators are, neither one of them are equal to 0, then to divide these fractions, to take a over b and divide it by c over d, we have to first change it to multiplication, and then we flip the second fraction. So notice that the c over d became d over c. Then we're ready to multiply, and so we multiply the numerators together to get a times d, and the denominators together to get b times c. Okay, let's look at an example. So here we're going to divide these two rational expressions. So the first thing to do is to change this to a multiplication problem and to flip the second fraction. So the first rational expression will stay exactly the same. The sign in between those two rational expressions will be changed to a multiplication symbol. And the second fraction, notice, got flipped over. So the 3x minus 9 ends up going on the top, and the 4x squared minus 12x plus 9 gets put on the bottom. So now it's just a multiplication problem. So we just proceed as usual, where we are going to factor everything completely first. So when you do your factoring, here's what you should end up with. So in the top of the first rational expression, there was a common factor of 4 to pull out. And then if you look at the trinomial that's left, it will factor into x plus 4 times 2x minus 3. So that numerator is factored completely. And then the denominator of that rational expression will factor into x plus 4 times x plus 4. And then the numerator of the second fraction, we can pull out a common factor of 3. So we end up with 3 times x minus 3. And then 4x squared minus 12x plus 9, if you factor that, you should end up with 2x minus 3 times 2x minus 3. So everything is factored completely. That's what we always want to do first when we're multiplying two rational expressions together. So now we're ready to cancel common factors. Notice we have a 2x minus 3 in the numerator and the denominator that can cancel. We also have x plus 4s in common. But now notice that on the top we have a 4 and a 3 and an x minus 3. Those three factors, and there are no factors in the denominator that match those three factors. So we're done canceling common factors, and we're ready to multiply. So we multiply the numerators together. So 4 times 3 would be 12. So we have 12 times x minus 3 on the top. And then on the bottom we have x plus 4 times 2x minus 3. And again, it's okay to keep those in factored form. And that's it. Alright, let's look at one more example. Look at an example of division where we have multiple variables again. So again, the first step when you're dividing rational expressions is to change it to multiplication and flip the second fraction. So notice that the first rational expression stays exactly the same. The second rational expression gets flipped around. So now if you want to pause the video and work on your factoring skills, go ahead and do that. So once you're done factoring, you should end up with these factorizations. So the first numerator in the first rational expression, we can factor out a y. So we end up with y times x minus y. And then its denominator factors into x plus 1 times x plus 1. Then in the numerator of the second fraction, you probably would need to use your grouping skills or trial and error to factor that into 2x plus 3y and x plus y. And the denominator of that fraction would factor into 2x plus 3y times x minus y. So now everything is factored completely, and we're ready to cancel common factors. So notice that the 2x plus y and 2x plus y, one on top, one on bottom, those will cancel each other out. We also have x minus y's in common. And notice that we have two factors left on the top, y and x plus y, and we have two factors on the bottom, x plus 1 and x plus 1. None of those are in common, so we can't cancel anything else. So we're ready to do the multiplication. So we multiply what's left on the top, and we get y times x plus y. And then in the bottom we have x plus 1 times x plus 1, and really if we want to write that in simplified form, since they're identical factors, we should rewrite that as x plus 1 squared. And that is our final answer. So I think that's enough for today. Hope you had fun. We will see you later. Bye-bye.